Hello, everyone. How are you doing today? I hope you're doing fantastic. I'm doing pretty well myself. You like my hoodie? This is actually one of my favorite hoodies. There's a specific reason why I'm wearing this hoodie today, and today we are going to be talking about NASA. The reason why we're going to talk about NASA is because they have done something pretty extraordinary over the past few days, and this extraordinary feat is known as their Project DART. And what DART is essentially is it's their attempt in building spacecraft to shoot themselves at a like a bullet at asteroids to veer their course off just ever so slightly, so that way these asteroids miss Earth. Because not only we have to worry about threats from neighboring foreign adversaries or even the onslaught wrath of Mother Nature here on Earth, but we also have to worry about threats that exist beyond our ozone layer in the final frontier. And what DART stands for is a Double Asteroid Redirection Test, hence the name. And one of the great parts about DART is that they just performed their very first successful planetary defense test a few days ago, and we're going to talk about it here today. After 10 months of flying in space, NASA's Double Asteroid Redirection Test, or DART, the world's first planetary defense technology demonstration, successfully impacted its asteroid target on Monday, the agency's first attempt to move an asteroid in space. Pretty huge. I can't even tell you how much this already means in terms of not future space travel for humanity, but also defending our own planet here on Earth. Because we have been extremely lucky so far with dodging asteroids, but this just takes us a step further to ensuring our own planetary defense as a preemptive measure to swave off any of these celestial bodies wanting to attack our blue marble. Mission control at Johns Hopkins Applied Physics Laboratory in Laurel, Maryland announced successful impact at 7:14 p.m. Eastern. As a part of NASA's overall planetary defense strategy, DART impact with the asteroid Dimorphos demonstrates a viable mitigation technique for protecting the planet from an earthbound asteroid or comet if one were discovered. At its core, DART represents an unprecedented success for planetary defense, but also a mission of unity with a real benefit for all of humanity, said NASA's administration Bill Nielsen. As NASA studies the cosmos and our home planet, we are working on to protect that home, and this international collaboration turns science fiction into science fact. As much as a science fiction guy myself, I love anytime something that I see in a movie or TV show or any sort of medium finally becomes reality. I'm still waiting on a lightsaber and Iron Man suit, which both things in their proto phase have already been done. But I think those are two of the coolest things that we have yet to see. DART's target, the asteroid moonlet Dimorphos, a small body, just 530 feet or 116 meters in diameter. It orbits a larger 2,560 foot or 780-meter asteroid called Deimos. Neither asteroid poses a threat to Earth. The mission's one-way trip confirmed NASA can successfully navigate a spacecraft to intentionally collide with the asteroid to deflect it, a technique known as kinetic impact. Or, in layman's terms, shoot that thing. Cool. I swear, we Americans just have a fascinating with shooting things. I think it's also a bigger flex than when we could shoot an asteroid to protect not only ourselves uh, but celestial bodies as well. So, and then later in NASA articles, they go into a little more detail about how the internals of it work. The spacecraft's sole instrument, the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, or DRACO, together with a sophisticated guidance, navigation, and control system that works in tandem with the small body maneuvering autonomous real-time navigation, or SmartNav algorithms, enable DART to identify and distinguish between the two asteroids targeting the smaller body. These systems guided the 1,260-pound or 570-kilogram box-shaped spacecraft through the final 56,000 miles or 90 1,000 kilometers of space into Dimorphos, intentionally crashing into it at roughly 14,000 miles or 22,530 kilometers per hour to significantly slow the asteroid's orbital speed. Draco's final images, obtained by the spacecraft seconds before impact, reveals that the surface of Deimos in close-up detail. They actually attached a video, which I'm going to play a speed through here. You're essentially getting a first-person view of this dart hitting the asteroid. Which is kind of funny now. Think about it. We finally can play Space Invaders in real life. With the asteroid pair within 7 million miles or 11 million kilometers of Earth, a global team is using dozens of telescopes stationed around the world in space to observe the asteroid system. Over the coming weeks, they will characterize the ejecta produced and precisely measure Deimos' orbital change to determine how effectively DART deflected the asteroid. The results will help validate improved scientific computer models critical to predicting the effectiveness of this technique as a reliable method. So what that segment is essentially saying is once they get the measurements of how far the asteroid is from Earth versus the point of impact, they can pair that up with the asteroid's intended path, so that way they can use that for more research, whether they can shoot the dart significantly faster, or if they need to hit it at a longer distance to see if that helps versus utilizing fuel. There's many different aspects that can come into play. I believe now that we as a collective group of people can feel safer knowing that we will soon have the capability to redirect asteroids from hitting our home blue world. But also, I think there's another interesting part about this. A few years ago, there was a huge story about a asteroid that housed about 700 quintillion dollars worth of gold on it. And everyone knows how valuable gold is. We use it for store of wealth. We use it in medicines and dentistry. It has a good use case in that. We also use it for computing and utilizing it in our electronics. It's extremely great in terms of conductivity, very similar to copper, but the only thing with gold is it's just an expensive commodity to come by. One of the things I think that would be very interesting is for this DART application is when it comes to asteroid mining, and this is just another product for it. If we can be able to predict the curve of an asteroid trajectory through Earth and essentially use technology similar to DART to redirect an asteroid to a given field. I mean, obviously it's going to take a little more time. It's not going to be anything that's going to happen anytime soon. If we are able to figure out how to essentially maneuver and drive an asteroid with minimal resources, because you got to keep in mind most of asteroids movement through space is with inertia and gravity. I predict it might not take as much resources to redirect an asteroid to a desired space within space to optimize it for easier access to mine and collect resources, because a lot of asteroids in space house precious materials like platinum, zinc, gold, obviously, and even some of them may house diamonds. So it just makes the idea for space mining a little bit more appetizing for the economic benefits that may come. You may say people, oh, it's going to crash the price of gold, or it's going to crash the price of diamonds, and I can get into that in another video, but all I can say is there's pretty much a few hand of people who control the whole diamond supply, which is why they're so expensive. And with gold, I much prefer cryptocurrency over gold. In America's gold was used more as a building material, and chocolate was the commodity seen as a store of wealth. Yes, chocolate. I have a lot of things. I can see this essentially becoming useful in many different applications outside of planetary defense. I didn't just name one with asteroid mining, but we'll see what comes of it. All right, everyone, that is all for today. My name is Ty Cooper, AOW. I hope you have a great day and on to a better tomorrow.